So hello everyone, welcome to the GFG problem of the day series. This is Achintya Singh. Today's problem that has been given is a easy question. The name of the question is min operations, and the question says that given two numbers a and b, in one operation you can pick any non-negative integer x and either of a and b. So one integer you have to take x and one you have to take either a or b. Now if you picked a, then replace a with a and x. Okay, just mark this line that we have to replace a with a and x, and if you are picking b, then b with b and x. Else if you picked b, then replace b with b and x. That's pretty clear. Return the minimum number of operations required to make a and b equal. Okay, let's see the input and output. If 5 and 12, then we have to return 2. Okay, fine. So after you can go with a naive approach of starting with a for loop and all those things. But instead of that, if you observe this question, or if you would have solved earlier any such type of question, there is an observation that performing and operation, okay, this is and operation, performing and operation with each other would be optimized and easy approach. Okay, so that's what I'm going to do. What I'm going to do is, the algorithm says, what algorithm we are going to use is start a while loop and run unless a is not equal to b. Fine. Check whether a is greater or b. So we have to check whether a is greater or b. Now if a is greater, perform a equal to a and b. That's pretty clear. That's pretty easy statement, that if a is greater, then we have to perform a equal to a and b, and this is what was given above also. That's why I told you to read the question properly. Then replace a with a and x, right? Okay, so otherwise if b is greater, then perform b equal to b and a. Okay, fine, that's we get it very clearly. Simultaneously we have to count also these operations. As we are performing these operations, we have to count also, because at last that is the thing that you are gonna return. Okay, and return at last count, as I told. Okay, let's try to perform this algorithm with some examples. Let's first declare a count variable that will be counting the number of operations equal to 0. Okay, fine. Now my example test cases are 5 and 12. A is 5 and b is 12. Okay. Now as you can see very clearly that b is greater than a here. So what we do is b equal to b and a, and here b is 12, a is 5. So 12 and 5 equal to, if you perform this on calculator or even if you perform with your hands, you will get 4. Okay. Okay, now we set the our new b as 4. Fine, and you have to increase the count also simultaneously. Okay, so count is now 1. Let's move down, because they both are still not equal, as a is 5 and b is 4, so they are not equal, right? So we have to perform once again. Now we see that a is greater than 5 this time. A is 5 and b is 4, so a is greater, right? So a equal to 5 and 4. You have to perform this AND operation, and you get, if you again solve in calculator or anywhere, you will get a equal to 4. Fine. Now you can see that a and b are equal. Now a is also 4 and b is already 4. So now as a equal to b, and count has been increased to 2 after this operation, so our answer is 2. That's very clear. Pretty easy algorithm, right? This will give you the minimum operations. Okay. Okay, now let's move towards the next example. A equal to 94 and I take b equal to 8. As you can see, a is obviously greater than 8, 94. So a equal to a and b, and a equal to 94 and 8. 94 and 8 will give me 8 if you perform it in calculator or anywhere. So count becomes 1, a becomes 8. Now as a is also 8, b is also 8, obviously a equal to b, and only one count we did, only one operation we did, so the answer is also 1. That's pretty easy, believe me. Now let's try to see. Okay, perfect, let's code. Come on, let's try to code and check it out whether this algorithm is giving the minimum or not. So as you saw, that first step towards this question will be, we need to declare a variable count, right? which will be keeping the track of the number of operations that have been made. The next step will be to initiate a while loop that will be checking whether A is equal to B or not. If it is not equal, then we have to execute this while loop. Okay. Further, we need to check whether A is greater than B or B is greater than A, right? Here I check whether A is greater than B, or in else if statement what I will do is if B is greater than A, right? Now in my if statement what I needed to do was A equal to A and B, right? My new A, my updated A will be A equal to A and B, right? The AND operation between A and B, and simultaneously I will increase the number of operation also because I did one operation here. Similarly, same thing. There's nothing difference. B equal to B and A, and my count becomes plus plus here it also because operation is being done. Fine, that's pretty easy. Now let's return our count, and that will be pretty easy. There is a base case that if they both are already equal, then you give 0. But this case is covering that also, because if you try to check whether 100 and 100, what is it? Okay, it is gonna come here while A is not equal to B, right? Already they are equal, so it will not come into the while loop and it will just return this count, which is already 0. So yeah, the edge case is also passing here. We don't need to check it separately. Okay, now when I run it out, I check that yeah, 5 and 12 is giving 2, and that is the expected output. Okay, so let's try to submit it and check it out how much time it is taking. So yeah, that is taking only 0.01. So really it is a easy question. According to yesterday, it is very easy. Thanks for watching today's video. I hope if you like the video, please do share it. uh, Thanks for watching. Let's meet in the tomorrow's problem of the day. Till then, bye bye, take care, keep coding. Jai Hind.